Hi everybody. This presentation will help you to understand about the data quality in GIS. The content of this presentation is what is data quality, and we try to understand the different components of the data quality and the possible sources of error in the data that we try to collect and use it for our analysis. Data quality basically refers to the ability of a given data set to satisfy the objective for which it was created. We have different sources of data, and all these sources of data will be encoded either raster or in vector format, which will be a spatial encoding, and also the attribute encoding will be done. And all these data sets, how well it satisfies your objective of your analysis is what we call it as the data quality. It is also defined as the measure of how well the GIS data represents the target domain. The target domain is the target analysis purpose for which you are designing this GIS. If you look at the data quality, we can see at two perspectives. One is at the macro level perspective, other one is at the micro level perspective. When I look at the individual data elements, that is called as micro level components. But when I look at the entire map as a whole set, the entire data set as a whole, I call that as a macro level component. What kind of possible data quality that we need to check at macro levels and micro levels? At macro level, the positional accuracy of the objects, the attribute accuracy, the entry data into the attribute, and the logical consistency in the maps, the resolution of the raster and vector is what we call it as the macro level components. And at micro level components, we need to look at the completeness of the object that we are looking at, the time at which the data has been collected, whether it is relevant for your work, and the lineage, the details about the process in which the data has been collected. So all these are the aspects in which we need to look at the data quality. At the macro level, the positional accuracy is the difference between the location of an object as it is described in the data and its actual location. So there are some terminologies that we need to understand if you want to understand the positional accuracy. One is the bias, other one is the precision. Bias is the systematic error, whereas precision is the standard deviation of the error. If you look at this first map, in this picture, you could see the green dots are the true location, and the data that you have created is given as red dots. So all the red dots are away from the green locations, which means that there is a systematic error in the map that you have created. So I call this as a high bias, which has a high systematic error. Now, whereas the second map, this map, if you look at the difference between the position of the green and the red dot, the true data and the data that you have created, the differences are not same in all the points, which means that it's not a systematic error, it's a random error is happening at different locations. So I call this as a low bias map with respect to the positional accuracy. And with respect to the precision, which I call it as a standard deviation of the error. Now again, look at this first map. This blue indicates the true position and the red one is the data that you have created, and you could see the positional locations of all these things. It is about the same distance. So with respect to precision, I say this as high precision. All errors are having about same distance, and here you could see it is not with respect to true locations. The data that you have created is not same at all points, so I call this as a low precision map, and the data quality is poor with respect to the positional accuracy. And with respect to the attribute accuracy, all the geographic objects that you have identified has to be entered with the attribute values. Sometimes there may be an invalid entry into the attributes. Sometimes there may be a missing attributes. You would have missed some attributes while entering, and there may be a mixed up attributes. Instead of entering a value in a other spatial entity, you would have entered in the one more spatial entity that would have created a mixed attribute values. This will create some trouble when you go for your analysis with respect to your attribute values. So this is one of the quality error that we need to correct it. And the next one is the logical consistency. This should consist of the relationship between the geographic objects. Okay, there should be a logical consistency in the map that you have created. For example, if you look at the diagram that is shown here, you have water body and the land, which has a common boundary that is indicated in the red line. Instead of that, when you this is the map that shows your digitized line. The blue line is the digitized line. The red line is the actual bifurcation between the water and the land surface, but the blue one indicates the line that you have digitized. So there is no consistency in your map which demarcates the relationship among the features. So this is the quality check that we need to look at before you go for your next level of analysis. And then next macro level component that we look at as a whole is the resolution that we need to look at it. If your map is a raster map, then we need to consider the grid sizes that will represent the real world units. The grid size should be able to capture the smallest unit that you are looking at for your analysis. If the grid is not able to capture your smallest object that you are intended for your analysis, then you have a quality problem. Similarly, in a vector map, the size of the smallest geographic object represented and the minimum mapping unit that you have should be able to compensate each other. So that is about the data quality with respect to the resolution. And coming to the micro level components, now we are trying to look at the individual objects. First one is the completeness of your data or completeness of your map, which is explained in three different categories. One is the coverage, classification, and verification. Coverage is the proportion of the data available for the area of interest. For example, you may have a study area and the data that you have collected from a different source. Your study area may be a watershed boundary and the data that you have collected is from an administrative boundary. If these two things are not proportionate for your area of interest, then that completeness is not there in your analysis. So the coverage is poor in that case. And classification, how well the classification is able to represent the data. Verification, the amount and distribution of the field measurements or other independent sources of information that were used to develop the data is what we call it as a verification. Some explanation is coming in the next slide. Completeness, if you look at, my area of interest is given in this black line and the data availability is given with the red line. Now look at this. There is no complete information for your area of interest or your study area, which means the quality of the data that you are using for your analysis is very poor. There is some missing data in these areas. So you cannot do a proper analysis, or in a simple word I can say, with respect to data quality, the coverage is not complete. So that is one of the data quality issues that we need to address when you go for your analysis. Next is the completeness. Under the completeness, you have the classification. For example, if my analysis is going at a level of finding out the type of crops that I grow, then if my data is going to have only at this level like agriculture, forest, urban and water body, my analysis is at the next level and my data availability is only at the previous level, which means my classification is not able to represent the data that I am looking at. So the classification accuracy is not able to help you to do the analysis, which means the data quality in terms of classification is not good. We need to improve this classification accuracy. Similarly, when you look at the micro level component, the time at which the data source material is being created is one of the very important data quality that we need to look at it if your analysis is based on your temporal analysis. Say for example, your elevation data or the topographical information may not change very frequently, which means I would have collected a data for previous year and I can use the previous year data for the current year also, assuming that the elevation will not change very significantly over a short duration of time. Whereas if you work at a highly rapidly changing urbanized area, the land use data and the population data is highly dynamic and you cannot use a previous year or old data for the current year analysis, which is very much dynamic. So in terms of data quality, the time at which you collect the data and the time at which for which you are doing the analysis is very, very important. You need to quality check at that analysis level. The lineage is the next micro level component, which is going to give us the history of the data set, from where the source has been collected, what are all the processing steps that is used to produce this data, and each data source and the processing steps that has introduced a level of error, and all those errors has to be identified because that is going to affect your final data product. Lineage should be encoded in documentation detailing how the data was produced and who did all these informations. And all these informations can be available at what is called as the metadata. So what may the possible error that you may encounter is during the data collection, there may be error in the field data collection itself, and that will accumulate in your analysis, and errors in the existing maps, that is that may be when you convert the data into a digital form, there may be some errors, and data input inaccuracies in your digitizing process. It may be due to the operator, or it may be due to the equipment's resolution, or the way in which you try to convert using a software like R2V. All those errors will be accumulating when you do your analysis. So then with respect to the data input, there may be error in the attribute entry also. So that also we need to check it out. And data storage, the numerical precision. Okay, your analysis may be with respect to one unit, and whether your attribute entry or data storage is going to store at that level of decimal precisions. So that also we need to look at it. There may be a possible error there which will accumulate when you keep on adding all these numbers or multiplying these numbers. That numerical precision will give you some error. And data manipulation, error propagation in multiple overlay operations. When you multiply many layers of maps, if one map has an error, that error may be propagating in all the layers when you try to do an overlay operations. And sliver polygons, which we have already discussed, which will also create some problem. And in the output, data output, there may be some error in terms of scaling inaccuracies with respect to the printer dots per inch, and the instability of the medium, and the use of results, misinterpretation of data, there may be a possible error. And no acknowledgement of the data uncertainty, there may be a lot of uncertainty in your analysis in terms of the data have a lot of uncertainty that has to be addressed when you do your analysis. And next one is the metadata. Metadata is all about the data about the data. It is like, if you look at a book, the book has a cover. The cover is going to give you the information about the book. The title of the book is the metadata, and the content of the book is the metadata. It gives you data about the data. The content is going to give you the information about the book or data about the book. So that is what we call it as metadata. And this consists of information that describes the spatial data and is used to provide documentation for data products. In GIS, metadata is who has created the data, what is the data is all about, when the data has been created, where the data has been created, and how well it is going to represent your data, how well is going to represent the spatial information that you are looking at. All those information should be there in the metadata. In all the GIS packages, there is a metadata provision where we can go and look at all these information. So metadata is basically the third component of the geographic data. Basically, the geospatial data gives you where the object is located, and the quality information is going to give you what it is, and the metadata is going to describe both geospatial and the attribute data, or the information about geospatial and the attribute data. So this is an example what the metadata should include. It should contain the date of the data uh, in which it has been collected, and the date of coverage generated, all the boundary coordinates, what are all the process that is involved, which software has been used, what are all the possible errors, and from where the original data came from, who did all these processing, what kind of a projection is being used, what is the assumption in the projection, what kind of a coordinate system has been used, what is the reference, the datum, in which unit all the maps has been presented, the spatial scale, attribute informations, to whom contact for further information. All these has to be included in a metadata. So in summary, with respect to the data quality, we have voluminous amount of geospatial data that are created, and it is given to the cartographic community, and the care should be taken by the individual geographic information system users to ensure that the data employed for their project is suitable for the task at hand. which means that you have a lot of data, and all those data you can encode it into your GIS, and the user has to check the quality of the data, because if the quality of the data is poor, whatever may be the process, the output is also going to be a poor. So as far as possible, check the data quality and ensure that it is free of error, and you should also define the uncertainty in your data. The user has to know what kind of an uncertainty that is available in your data set. That is the end of the presentation. Thank you.